Hey, I'm Nick Whitaker. I'm from Oakville Trafalgar High School. Our competition ID is 18.
I'm a member of the Oakville Trafalgar High School First for Inspiration and Recognition of Science and Technology Robotics Team 1334, and our robot's name is Hank, which stands for Harbinger of a New Cool. Hank was built to play the 2011 first robotics competition game known as Locomotion. The objective of the game was to place inflatable inner tubes in the shapes of triangles, circles, and squares on a vertical scoring rack with 3 different levels, the highest rung being 10 feet high. Additional points were awarded for the arrangement of the game pieces. In the last 10 seconds of the match, robots could deploy what are known as mini-bots up a 10-foot pole for bonus points. The key to any FRC game is to score points as efficiently as possible. To accomplish this, Hank was designed to quickly pick up tubes from the ground and score them. The wide paddle gripper is used to grab tubes on the fly from the ground, even at off angles. After securing the tube, the pneumatic wrist then lifts the tube to a vertical orientation. The elevator is driven up to the desired preset peg height and the tube is scored. Grounding all of this is a very robust and simple 6-wheel drivetrain with 2 speeds. The lower gear is used for fine alignment and getting through defense, where the higher gear is used to quickly get across the 54-foot field. Hank is a functional competition robot. Our robot has many sub-assemblies, each of which is unique. One key design element is found in the mini-bot deployment mechanism. It is comprised of a pneumatically activated drop-down ramp, with steel track as the surface. This allows the mini-bot, which uses neodymium rare earth magnets to apply the necessary normal force to stay attached to the pole, to transition smoothly from the robot to the pole. A second pneumatic cylinder activates an on-off switch on the mini-bot, causing the mini-bot to literally drive itself up the ramp and onto the pole. Another key feature with this system is its ease of alignment against the pole. As the robot drivers don't always have a clear view of the field, a foolproof system was in order. In the deployment arm, there is both passive rotational freedom, in case the robot drives up to the pole on an angle, and passive linear freedom, to take up the distance in effective arm length. So long as the drivers can get the pole within the 18-inch window the guiding V offers, the deployment arm will be properly aligned. A third design element to note is the integration of sensors into the autonomous control of the robot. The first 20 seconds of every game is completely autonomous, and Hank will score a tube on the high level during this time. Hank uses 4 distinct sets of sensors to accomplish his feat. Firstly, there are 3 infrared sensors looking at the ground that detect a line on the floor. Using the line tracking in the code, Hank will always be on target. Incremental rotation encoders are used on both the drive wheels and the elevator to ensure repeatable distances and heights respectively. Lastly, an ultrasonic rangefinder is used to detect the distance from the wall behind the scoring pegs. This feedback is used to get Hank to stop and then score the tube at the correct distance every time.